So the next thing we're going to talk about is rationalizing the denominator. And what that means is that we eliminate the radical or the root sign in the denominator. It's not proper, so we don't like it. And so the best thing or the easiest way to do that is we just multiply the top and bottom of your fraction by whatever the denominator is. And so in this case, we have a denominator of 3n. So we're going to multiply the top by 3n. And remember that 3n, or the square root, I should say, the square root of 3n over the square root of 3n is the same thing as 1. So we're really not changing the problem. We're just rewriting it in a different form. And so then we just multiply what's under the radical. So they're both under the root sign. So we're going to go 5 times 3n. And on the bottom, we're going to go 3n times 3n. So basically, I'm just multiplying by what's under the radical for both of them. And then when I go to simplify, it's just that easy. On the top, you don't have any pairs because remember, there's really an imaginary 2 sitting here. Because I don't have 2 of the same prime factor, I'm just going to multiply them together to get 15n. But on the bottom, you do have a pair. You have a pair of 3s. So a 3 is going to come out. And then you have a pair of n's. So an n is going to come out. And so my answer then is root 15 over 3n. When I look at b, kind of the same thing. I'm going to multiply both sides by the 4x to the third. Now, I can simplify that first if I wanted to. Let's think about this for a minute. If this is 6 and I break down 2x to the third, this is the same as 2 times 2 times x times x times x. And so when I look at it that way from the beginning, I can see that I have a pair of 2's and a pair of x's that can come out. So this is really the same thing as 6 over 2 and an x, and a root x is left in the bottom. So when I go to get rid of this root x, I need to multiply the top and the bottom by root x. I don't need to worry about this 2x because it's not under the radical sign. And so as we do that, we get 6 root x over 2x. And then as we think about this, this is the square root of x times x because they're both under the radical, so we can combine them. And now we have a pair of x's that gets to come out. So we have 6 root x over 2 times x, which simplifies down to be, remember that 6 is divisible by 2. 2 goes into 6 3 times. So we're left with 3 root 2 over x squared because we have 2 x's on the bottom, so we can add our exponents together. So this would be our answer on the bottom. When I look at C, same idea. I'm going to break it down first. So this is 2, and this is cubed root of 9, which is 3 times 3. And I, in this case, need 3 of a kind in order to pull something out of the radical, and I only have 2. So what that means is I need to give the top and the bottom another cubed root of 3, because now the top is going to be 2 cubed root of 3, and then the bottom is cubed root. We already have the 3 times 3 from before, and now the third 3 is going to go underneath. So now we've got 3 3's underneath. And as I look, again, I'm looking for 3 of a kind because the 3 sits on the shelf. So I have 3 of a kind. So that's going to come out. So I'm going to go 2 cubed root of 3 over 3. And this is my answer. So when it's one term or a monomial, well, I guess just one term. When it's one term, it's not a monomial because it has a fraction exponent. But when you have one term underneath the radical, underneath the division bar, then I can just multiply by the top or the bottom. But the next thing we're going to talk about is when you have 2 terms. So notice that you either have it saying plus or you have it saying minus. So it's 2 terms combined together. And when that's the case, then we have something called, we have a term or 2 terms where we need to multiply by the conjugate in order for me to get the radical to go away in the denominator. So as I look at example 5, I'm trying to get rid of 2 minus root 3. So because this says minus root 3, the conjugate is 2 plus 3. So this is 2 plus root 3. So the sign changes. And then from there, we're just going to multiply. So basically, this little 7 is going to get distributed to both pieces. So 7 times 2 is 14. And remember, there's an imaginary 1 out here. And so when you multiply, it's just like we did earlier, like outside times outside, inside times inside. So this 7 is on the outside of the radical. So it multiplies with the number on the outside of the radical. So 7 times 1 is 7. And the root 3 is just going to get tagged on next to it. And then on the bottom, we're going to look at that really quick. So on the bottom, if I was going to multiply those two together, this is 2 terms, so we can multiply 2 terms by 2 terms. So we're going to go 2 negative root 3 and 2 positive root 3. And just like before, it's as if there's ones in front of these, and we just multiply. So 2 times 2 is 4. 2 times 1 is 2 root 3. And negative 1 times 2 is negative 2 root 3. And negative 1 times 1 is negative 1. And then root 3 times root 3 is root 9, or 3 times 3. And I'll just leave it like that for a minute. Because when you go to simplify, 4 you can't do anything with, 2 root 3 you can't do anything with, negative 2 root 3 you can't do anything with. But the last box you can. You have a pair of 3's. The pair of 3's makes it go on the outside, so this is negative 1 times 3, which makes this box really be the same as a negative 3. And now when I look at diagonals, I have 2 things that I can do. These 2 added together give me 0. These 2 added together give me 1. So this is a 1 on the bottom, and anything divided by 1 is itself, so my answer is just going to be 14 plus 7 root 3. And when you multiply, so over here to the side, it talks about how if you're multiplying a number times its conjugate and you do this whole box every time, then you're always left with a squared b minus c squared d. So basically you're left with these 2 boxes. So you're going to be left with these 2 boxes every single time. And the other 2 boxes cancel out every single time because one's going to be negative and one's going to be positive. And so what you're going to see that as we go through what I'm talking about, you're going to see that happen over and over again. So as we look at the next page and we're looking at monitoring progress, the first example is how do we get rid of root 5? So we're going to multiply because it's only one term. We just multiply the top and the bottom by the bottom. So that radical 5. And then the top, we just multiply. So the one's on the outside and there's another one on the outside. So when I multiply them, I get 1 root 5. And then on the bottom, I get 5 times 5. You look for pairs. So there's a pair of 5. So it's going to come on the outside. So we get root 5 and a 5 is going to come out because you have a pair. And then number 2, same idea. Radical 3 and a radical 10. So we've already split it. So we need to get rid of the bottom and it's one term. So we're going to multiply the top by 3 and the bottom by 3. And when I multiply the top by 3, I can either go 10 times 3 or you can get 30. And on the bottom, you get 3 times 3. And again, we're looking for pairs. So when I look at 10, 10 really is the same thing as going 2 times 5 times 3. But you'll notice in 2 times 5 times 3, there's not a pair there. But on the bottom, there is a pair of 3's that comes out. And so if I multiply the top back together, that's going to give me root 30, and the bottom's going to be 3, and you're done. Remember that I can't divide underneath the radical. The little radical sign is like a house. It's protecting it. You can't just break in, okay? You have to, in order for you to go in, you both have to be under the radical. All right, so you can't divide there. Same thing here with 5 and 5. It doesn't make it so you can go further. All right, I think that's good for video 3. Video 4 will pick up with problem number 3.